Electric current is the flow of electric charge. In solid conductors, electrons carry the charge through the circuit because they are free to move throughout the atomic network. Protons are bound inside atomic nuclei, locked in fixed positions. In fluids, such as the electrolyte in a car battery, positive and negative ions as well as electrons can flow. Electric current is measured in amperes, abbreviated with the symbol A. An ampere is the flow of 1 coulomb of charge per second. While the current is flowing, negative electrons move through the atomic network of positively charged atomic nuclei. Charges won't flow unless there is a potential difference, also known as a voltage difference. Voltage is related to potential energy. It's the electric potential energy per charge. The unit of voltage is the volt, abbreviated with a capital V. Electrical engineers and electricians often think of a voltage difference as an electrical pressure that pushes charge through a circuit. Something that provides a voltage difference is known as a voltage source. Batteries and generators are capable of maintaining a continuous flow of electrons. In a battery, a chemical reaction releases electrical energy. Generators, found in windmills, power plants, and the alternator in your car, convert mechanical energy to electrical energy. The electrical potential energy produced is available at the terminals of the battery or generator. The voltage provides the electric pressure to move electrons between the terminals in a circuit. Power utilities use electric generators to provide the 120 volts delivered to home outlets. When the prongs of a plug are inserted into the outlet, an average electric pressure of 120 volts is placed across the circuit. This means that 120 joules of energy is supplied to each coulomb of charge that is made to flow in the circuit. There's often some confusion between a charge flowing through a circuit and a voltage being impressed across a circuit. Charges flow through a circuit because of an applied voltage across the circuit. You don't say that voltage flows through a circuit. Voltage doesn't go anywhere. It's the charges that move. Voltage causes current. The amount of charge that flows in a circuit depends on the voltage provided by the voltage source. The current also depends on the resistance that the conductor offers to the flow of charge, the electric resistance. The resistance of a wire depends on the conductivity of the material on the wire and on the thickness and length of the wire. Thick wires have less resistance than thin wires. Longer wires have more resistance than short wires. Electric resistance also depends on temperature. For most conductors, increased temperature means increased resistance. Thanks for joining me, and see you next time.